There's a lot of money flowing under the sea these days, and we're not talking about sunken treasure. We're talking about the world's longest and deepest tunnel connecting Scandinavia to the Mediterranean. This $11 billion tunnel is currently under construction, and when it's completed, it will be a feat of engineering ingenuity. But what's even more fascinating is what's going on inside the tunnel right now. Hello everyone and welcome back to the channel. Join us as we take a look at the construction of this massive tunnel and see what it takes to connect two continents. The ScanMed corridor extends from Finland all the way down to Malta, and due to a bridge over the water in Copenhagen, it's all very simple traveling until you hit the Alps. For decades, this has hindered transport, creating a torturous bottleneck on an otherwise smooth highway. To address the issue, the EU is now developing an $11 billion tunnel right through the heart of the Alps to link Scandinavia with the Mediterranean. The Brenner Pass at 1,371 meters above sea level is the lowest gateway over the Alps and may be used all year. Today, the Brenner Pass transports 40% of all freight through the Alps. However, owing to the steep inclines and the effect on railway speed, more than two-thirds of freight is transported by road. This, along with the region's leisure business, made the area known for traffic congestion, noise, and bad air quality, and the EU decided to intervene in 1994. Because modifying the current railroads would be impracticable owing to the topography, the decision was taken to build a whole new railway tunnel straight through the mountains, avoiding the steep inclines and meandering paths that slow trains down. The primary path of the Brenner-based tunnel will extend for 55 kilometers, beginning in Innsbruck, Austria and ending in Fortezza, Italy. When linked to the Innsbruck bypass tunnels constructed in 1994, the project will become the world's longest underground train connection, with a total length of 64 kilometers, exceeding even Switzerland's Gotthard-based tunnel. The overall project includes an exploratory tunnel that will be used to assess the route's ground conditions prior to construction and will serve as a drainage system once completed. Twin main tunnels 70 meters apart that will carry trains in either direction, and 4 lateral access tunnels that will connect to the surface and allow spoil and materials to be moved in and out. If that wasn't enough, the two major tunnels are linked every 333 meters, and 3 emergency stations have been built 20 kilometers apart to offer escape routes and sanctuary for passengers in the event of an emergency. Work started in 2008, and excavation has continued for more than a decade across 4 major locations. It should come as no surprise that excavating a lengthy tunnel through a mountain is difficult, and this is no exception. Because the route passes through 4 separate rock types and one of Europe's longest fault lines, tunnel construction is divided nearly 50-50 between classic blasting and tunnel boring technologies. Explosives are put into pre-drilled holes and detonated to form blasting sections. Mucking is the process of removing loose debris using heavy machines. After the surface and anchors have been removed, shotcrete is used to stabilize them, and lattice arches and reinforcing matting are laid to give it structural support. The whole process then continues and repeats itself. The TBM parts are in theory more easy. As it goes ahead into the rock, the machine excavates material, removes it through conveyor belts and reinforces the tunnel itself. With an inner diameter of 8.1 meters, the project will unearth an amazing 21.5 million cubic meters of material, with about 1/3 of this material recovered and repurposed as concrete aggregate inside the tunnel itself. The remainder will be disposed of in a sustainable manner at 5 locations along the route, functioning as fill for regions that may be reforested and manicured after the project is completed, restoring the site to its original usage. When finished in 2028, some 20 years after work started, the very straight Brenner-based tunnel will enable trains to achieve 200 kilometers per hour, and the route from Innsbruck to Fortezza will be reduced from 80 minutes to 25 minutes. It's a marvel of engineering that will build a cleaner and more sustainable transportation connection not only between two nations, but from Scandinavia all the way down to the Mediterranean. This brings us to the end of the video. Don't forget to like, subscribe, and share. Also, click on the notification bell to get notified every time we upload a new video.